Hello, my name is Strahinja Jokic and I'm a master student at the Thermal Group of Mechanical Engineering at the University of Twente. Currently, I'm doing my master thesis titled Energy Saving Potential of Cooll's Heat Pump in a company called Cooll Sustainable Energy Solutions. As you know, there is a climate target plan to reduce the CO2 emissions by 2030, which is accompanied by the increase in energy efficiency. I would like to point your attention to the housing sector. So the Netherlands has approximately 7.8 million homes, of which more than 85% is heated with central heating boilers. About 90% of the total Dutch CO2 emissions can be attributed to these homes. Almost two-thirds of these CO2 emissions are attributable to space heating and hot tap water, which makes them the largest contributor to the CO2 emissions of households. The CO2 emissions for space heating of new buildings are relatively very limited due to good insulation and lower heat demand. The greatest savings of space heating must therefore be achieved in existing homes that are now largely heated with gas-fired boilers and high-temperature heating systems. This is therefore the major challenge both economically and technically. Cooll offers a solution in the form of the absorption heat pump, which is a one-to-one replacement for the high-efficiency gas boiler. The heat pump is powered by gas and extracts heat from outside air. However, compression of the refrigerant now takes place within a heat-driven absorption compressor instead of an electromechanical compressor. The required heat comes from a burner, and it is a cyclical process that takes approximately around 10 minutes. The benefits are numerous. Some of them are the reduction in CO2 emissions from 30 to 50%. The technology is ideally suitable for more sustainable energy carriers. It is possible to add cooling as an option, and it is possible to replace the high-efficiency gas boiler with this specific heat pump. In Cooll, my tasks revolve around system modeling and system integration. The main gap was the absence of a good heat pump model that can quantify the energy savings and capture the heat pump behavior with sufficient precision on a year-round level. It is also important that the developed model is flexible and easily applied in different system configurations. Newly developed model takes into account three independent variables and allows simulation in a time-dependent system. With this new model, the goals of assessing the energy savings on a year-round level can be completed. The results for an average house in the Netherlands with radiator heating and a constant set point of 20 degrees are shown on the screen. The comparison is done between the condensing boiler reference case and Cooll's heat pump. As you can see, it is possible to save 30% in the gas consumption on a year-round level if you're using Cooll's heat pump. Possible applications for the future could be the sensitivity analysis of a typical house and control strategies in different climates, evaluation of gas savings in different climates, addition of the domestic hot water system in the model, and the modeling of the complex system using PV or PVT. Thank you for your attention and enjoy the rest of the presentations.